Welcome back. This is Mr. Hassan's Maths channel, and I'm answering question number 7 from the June 2014 Core Mathematics C34 International A-Level Edexcel exam. This is a question about functions, which is now under the new P3 specification. Part A, it says, first of all, it says the function f is defined by this. F is such that x maps to 3x minus 5 over x plus 1. This is the same as if they wrote f of x equals 3x minus 5 over x plus 1. They actually, basically mean the same thing. All right? It's just different ways of writing functions. So it says find an expression for the inverse of fx. The inverse of fx. So first of all, algebraically, we want to find the inverse function. What we're going to do is I'm going to take my original function f of x equals 3x minus 5 over x plus 1. And I'm going to change the f of x for y. So it'll say y equals 3x minus 5 over x plus 1. So the first step I like to do now is I like to replace the x with the y with the x and the x with y. So I'll write this as x equals 3y minus 5 over y plus 1. I'm just, wherever I see x, I'm replacing it with y, and wherever I see y, I'm replacing it with x. Now I want to make y the subject of this. When I make y the subject of this, what I'll be left with would be the inverse function. So what I'm going to do first is I'm going to multiply both sides by y plus 1. So I'll multiply this y plus 1 with x. So I'll have x times y plus x times 1 equals 3y minus 5. So I've just multiplied this and expanded the bracket in one step. Now I want to bring the y's on one side and the x's on the other side. So I could subtract x from both sides and subtract 3y from both sides, but it will look like a bit strange because I'll have minus x minus 5. I would like it to make it look a bit neater. So what I'll do is I'll keep this side for the x for everything else and this side for the y. So I'm going to add 5 to both sides. So I'll have x plus 5, and I'll subtract xy from both sides. So I'll have 3y minus xy. Now when I make y the subject, there's two y terms. So what I can do is, let me make some more space here. Put this down here, deal with that later. Now what I can do now is I can take this y as a common factor of these two terms. So I have y times 3 minus x in brackets, and this side I have x plus 5. Now I can divide both sides by 3 minus x. So I have x plus 5 divided by 3 minus x equals y. And therefore I can say the inverse function of x is going to be x plus 5 over 3 minus x. And we should really give the domain for this function. Okay, and we can see that the domain for this function is x cannot equal 3. X cannot equal 3 because when x is equal to 3, this becomes undefined. Okay, so that's the domain of this function, and x is all real numbers apart from 3. Okay, something like that. We should give the domain. You should always give the domain for the functions that we are asked to find. As this is unrestricted in terms of it includes all real numbers, that means this will also be unrestricted. But the only thing is, any number that causes it to be undefined will be excluded. Now, sometimes some students ask, how can I work out how to sketch this graph? Or how can I work out what the asymptotes are for this? Supposing we were supposed to write for example, if they ask us to find the range of this function. They asked us to find the range of this function. Supposing the question asked us to do that. How would I do this? This is not part of this question, by the way. The question doesn't ask us to do this. I'm kind of diverging and going off on a tangent because a lot of students do ask this question. I want to address that now. All right? So, that's why sometimes my answers take a lot longer than they should do, because sometimes I go off and talk about other matters which I'm asked about quite often. So I use this opportunity to go through those. So my apologies for that. But I think it's important sometimes to do this. So now, how would I work out the range of this function? Well, the range of this function are the y values it can take. Right? So in order for us to work out the range of the function, we should try to picture what it looks like. Now, what type of function is this? Well, this is a reciprocal function because you're dividing by, you have x in the denominator. And the original type of function which is reciprocal has this type of shape. It's 1 over x. This is the original type of function. Y equals 1 over x. That's how it looks like. That's like the parent function of the reciprocal functions. Something like that. I don't know, is that straight or not? I can't. That is, okay, good. All right. So in this function, you actually have two asymptotes. You have two asymptotes. You have your horizontal asymptote, which goes like this, and you have your vertical asymptote, which goes like this. There's 2 points or two lines that the curve can never touch. So that it gets closer and closer to those points without touching them, like this. Okay, so that's what the basic parent function looks like for a reciprocal function. Now, how can I draw this function or think about what this looks like or work out what the asymptotes are? Well, the vertical asymptote is very easy, and it's actually mentioned here in the domain. Any value that makes the denominator 0 is going to be an asymptote. So you can say, take the denominator, and you say that can never equal 0. That means x can never equal -1. So x equals -1 would be the asymptote for this. So the asymptote for this is now going to be -1. Okay, it looks something like this. So I mean, just from looking at that part. Okay, so I'm actually going to stop drawing it now. I'm just going to show the asymptote has moved there, and then we can draw the graph around it afterwards. So that's the horizontal, the vertical asymptote. Sorry, x equals -1. Now the vertical asymptote, and we have 1 over x, is basically going to be found by the transformation of this asymptote if it moves up or down. How does this move up or down? Well, that's the whole graph moves up or down when you add something to the whole function. So what is added to 1 over x for it to become like this? Okay, so you got to think about how this would look like as a mixed number. Okay, now if you converted this into a mixed number, you'll have x plus 1 going into 3x minus 5. X into 3x goes 3 times. That's the whole number of times it fits in. And there's going to be remainder found by doing this. 3 times x, which is 3x. 3 times 1, which is plus 3. So when you subtract these, you're going to have -5 minus 3, which is -8. So that's the remainder, and that's the whole number part. Okay, so what we can say is this, when you've got 3x minus 5 divided by x plus 1, you're left with 3 as a whole number, and then the remainder is -8, which goes over the original denominator x plus 1. So this is how this function looks as a mixed number. So you can see what's added to the whole function is a 3. So this horizontal asymptote moves up by 3 units. It becomes y equals 3. Okay, so those will be the asymptotes. Now, how do we work out where the graph passes through? Does it go through this side, or does it go through these two sides, or does it go through those two sides? 1 over x, as we know, goes through these two sides. But if there's a minus in front of this, it's going to go through the other two sides. It's going to swap, and we can see that from here. It's going to go through, instead of going through these two sides, okay, as it does with 1 over x, it's going to go through these two sides. It's going to go like over here, and then over here somewhere. Before I'm going to draw where it goes through, I'll find out where it hits the x and y axis. Now, when it hits the y axis, when x is 0, you're left with -5 over 1, which is -5. So it goes through the y axis at -5. So we know for sure it's going to go something like this. And even you want to work out where it goes through the x axis, you put y equals 0. So 3x minus 5 equals 0. So x equals 5 over 3. So it's definitely going to go through those two parts for sure. So it'll look something like this without touching the asymptote, of course. So that's how it will look. Now, how could I have worked out, without changing it into this improper fraction, what the horizontal asymptote is going to be? Well, it's very easy, because you have 3x minus 5 over x plus 1. You just take the x coefficients and divide them. Okay, because that's what's going to happen when you do this long division. So 3x divided by x gives you 3. So that means y equals 3 is the horizontal asymptote, and x equals -1 causes the denominator to be 0. So x equals -1 is the vertical asymptote. So that's how you can find out without actually, splitting it into this improper fraction, and to work out how it looks in terms of does it go in this side and that side, or that side and that side, you just find that, using this you can put x equals 0 to find where it hits the y-axis, and y equals 0 to find where it hits the x-axis, and then you know for sure that it goes in this side and that side, and then you've drawn your function. All right, so that's just a little side point which isn't part of the question, just to answer some of the questions that some students have asked me in the past, how we can work out how to sketch this without having to turn it into an improper fraction. Okay, I hope that was clear. All right, so whenever you're asked to give the find the inverse of a function, even if it doesn't tell you to express the domain, you should express the domain. All right, and in this particular question, all right, it's pretty simple. You don't really have to even think about the sketch, but there might be some questions where they have restricted the domain. Okay, like for example, they might have said, x is greater than 2, for example. X is greater than 2. Actually, it was the other way around. Sorry, it was in the other two quadrants, wasn't it? Okay, supposing they had said, the domain is x is greater than 2. Okay, that means when x equals 2 is where the graph is going to start. Open circle there means you get rid of everything else apart from that part of the graph. Get rid of all of this part. Okay, and the graph only exists when x is greater than 2. So for example, if they said find the range of this function, okay, you can find the range of this function would be the domain of the inverse. Okay, so if we find the range of this function here, okay, the range of this function is going to be between these two values. Okay, and we already worked out that this is y equals 3. But what is this value? Well, we work out when x equals 2, you have f2 is 3 times 2 minus 5 over 2 plus 1. That's going to be 1/3. So this would be 1/3. So the range of this function would be the range of the inverse function here. The range of the original function here. Okay, let's just call it y. The range of this function would be between 1/3 and 3. So it would be greater than 1/3. It won't equal 1/3 because there's an open circle here. If this was greater than or equal to 2, then that would then be a closed circle, and that would be equal to. And it goes as far as just before 3. Okay, because that's an asymptote that never reaches 3. So that would be the range of this original function, and therefore it would be the domain of the inverse function. So if they gave it like restricted like this, then that would be the range of the original function, and it would therefore be the domain of the inverse function. Okay, it would therefore be the domain of the inverse function. But it wasn't given to us restricted, it gave it as all real numbers. So all of that stuff, of course, we don't have to do. I'm just showing you what to do in different kinds of situations, how to deal with this type of problem. So that stuff wasn't there, but I'm just giving you an idea of what to do if it was. All right, so this is the answer here. That's the inverse function. That's the domain of the inverse function. Always mention the domain, even if they don't tell you to. Okay, and this one is pretty simple. We don't have to really worry about anything. We know that the domain is going to be all real numbers, as this is all real numbers. Okay, and x cannot ever equal 3 because that is the number that can't go in the denominator. That's the only thing you have to exclude from the domain. Okay, so that's part A done. Now for part B, it says show that the composite function f of x is equal to x plus a over x minus 1, where x is an element of the real numbers and x cannot be minus 1 nor can it be 1. Okay, so this is the original function here, f of x. And the reason why you can't have minus 1 in the original in the composite function is because it cannot be in the original function. So that has to be there. And the reason why x cannot equal 1 in the composite function is because, as we can see, you're going to end up with x minus 1. So x can't be 1 because that will make it the denominator 0. That's why both of these cannot go into this function, because the original function that this composite was made from cannot take minus 1. So therefore this function cannot take minus 1 either. And this cannot take 1 as well, because when you find the composite function, that becomes something that causes it to be undefined. Okay, so now, how do you find f of x? Well, how do you find a composite function? What we do is we take the second function and substitute it into the first. So I'm going to do this. I'm going to take the second function and substitute it into the first function. So I'll take what f of x is equal to, which is 3x minus 5 over x plus 1. And I'm going to substitute that into the original function. So I'm going to replace the x in this function with this expression. Now, if you don't understand that, supposing I said find f of, say, 5. That means I would replace the x in this function with 5. So 3 times 5 minus 5 over 5 plus 1. Okay, so whatever's in this bracket replaces the x in this function. That's exactly what we're doing here. I'm replacing this x with 3x minus 5 over x plus 1. So I'll have 3 times 3x minus 5 over x plus 1. Then I've got a minus 5. That's 3x minus 5. X is replaced with whatever's in there. Divided by, I have x plus 1, so I replace the x with this thing, which is 3x minus 5 over x plus 1, and I've got plus 1 at the end. Okay, now, how do I deal with this? Well, remember, this 3 is just multiplying the numerator here, so it's not like 3 times both of them. This is like 3 over 1 times that. So what I can do here, a nice little trick to get rid of the denominators inside this fraction, is multiply both the numerator and the denominator of this by x plus 1. Okay, if I multiply this by x plus 1, the x plus 1's cancelled, and I'm left with 3 times 3x minus 5 minus 5 times x plus 1. So multiply this x plus 1 with this term, x plus 1's cancelled, multiply with this term, I'm left with minus 5 times x plus 1. That get rid of that denominator from the numerator of this. And then if I multiply this term by x plus 1, 3x minus 5 over x plus 1 times x plus 1's cancel, leaving you with 3x minus 5, and then you have 1 times x plus 1. 1 times x plus 1. So now we're left with this. Let's expand the brackets on top and simplify. That's going to be 9x minus 15 minus 5x minus 5 over, this is 3x plus x, which is 4x, minus 5 plus 1, which is minus 4. That gives me 9x minus 5x, which is 4x, minus 20 over 4x minus 4. Now that can be simplified because there's a common factor of 4 on both the numerator and the denominator. That's 4 times x minus 5 over 4 times x minus 4. Minus 1, sorry. That's, x minus 1. Those 4's cancel. I'm left with x minus 5 over x minus 1. So we can say the composite function f of x is equal to x minus 5 over x minus 1, which is the right form that we wanted. X plus a over x minus 1. The a is, of course, negative. So a is negative 5. So a is equal to negative 5. We have the domain is x is all real numbers except for x cannot be 1 because of this, and x cannot be negative 1 because the original function, you can't have negative 1 in that. Okay, so there's the answer to this question. Question number 7, part B. Okay, now I'm going to move on to 7, part C. Okay, now it says the function g is defined by g of x equals x squared minus 3x. Find the value of where g is such that x can be only between 0 and 5. Find the value of fg2. So fg2. So we got to first find what g2 is and then replace that in here. So we've got to find fg2. So let's first find what g2 is. g2 is found by putting 2 inside this function, which is going to give you 2 squared minus 3 times 2, which is 4 minus 6, which is negative 2. Okay, which is negative 2. Let's have a look here. Okay, so now we got to put the value of g2 into the function f. So fg2 2 is the same as f minus 2, because that's the value of g2. So we've got to put negative 2 inside the function f. So that's going to give us 3 times negative 2 minus 5 over negative 2 plus 1. That's going to give you negative 6 minus 5, that's minus 11 over minus 1, which gives you 11. So there's the answer. F G2 is equal to 11. Okay, so that's the answer to part C. We could have found the composite function fgx first and replaced the x with the 2. So I could have found what fgx is first by replacing the x in function f with what gx is. So I could put 3 times x squared minus 3x in brackets minus 5 over x squared minus 3x plus 1 in and then replace 2 inside that function. But I think that's going to take a lot longer than this. This is way easier to deal with in this way. Okay, but that is also an option if you wanted to do it. Now part D says find the range of function g. Now this is a very important question, because as you can see, g has got its domain restricted. G has got its domain restricted between 0 and 5. So if the question just had this, it would be slightly different. So first of all, this is a quadratic. We can see it's a quadratic because the highest power is x squared, and we can see that the coefficient of x squared is 0, so it's definitely going to have this type of shape. So this is going to have a minimum vertex below which it will never reach. Okay, so if I was to draw this unrestricted, I would have to find where the vertex is, which can be done in a number of ways. One of the easiest ways of doing this is by completing the square. So I can rewrite g of x in a form where it's completed the square. So I have x squared minus 3x. So to complete the square, I'm going to write x minus a half of that coefficient squared, take away the square of this number, which is 9 over 4. Okay, so that is completing the square for this. And the vertex of this function is going to be the value of x that caused this bracket to be 0, which is 3 over 2. And what's left over at the end, which is a negative 9 over 4. That is the vertex of this function. Okay, so to find the range, that's important for us to deal with, know the vertex. This is basically as decimals 1.5, and this is minus 2.25. Okay, that's 2 1/4, right? Okay, so if we were to make a sketch of this, always making a sketch is very useful when we're dealing with functions and finding the domain and the range. It's very important for us to think about how it looks. So this graph will have the vertex at 1.5 and minus 2.25. This is the vertex. And this is going to pass through the origin, because when x is 0, y is 0. And it's also going to pass through the point where x equals 3. Because you have x times x minus 3 equals 0, x equals 0, x equals 3. So it's going to go through these 2 points. So it's going to have this type of shape, this smiley face type of shape. Let me just draw it first and then put the point. I'll draw it first. I won't put these values in. I'll just draw a nice parabola shape. Going through the origin though. Okay, I'll do this even. I won't even put this in yet. I'll just draw a nice parabola shape. That's how I like to do it. Forget about the axis there. Just draw the shape. Make it look like a proper parabola. And then say, okay, it crosses the x-axis at the origin. So that's where the y-axis is going to be at 3. And the vertex is at the point 1.5 and minus 2.25. That's the vertex. Right now, if this question had no restrictions on the domain, then we can say the range of the function, we can say g of x is greater than or equal to negative 2.25. That would be the answer, because it continues up forever this way and this way. It never goes below this point because this is the vertex. However, this question has a restricted domain. It's only between 0 and 5. So all of this part is gone. It starts from 0. And it only goes up to 5. So I've got to think about what happens at 5. Just say this is where x equals 5. Okay, so it stops where x equals 5. So I've got to work out what the y value is there. Okay, when x equals 5, you can say that the function g5 is going to be 5 squared minus 3 times 5, which is 25 minus 15, which is 10. So this is 10. So the range of the function, well, it's not between 0 and 10, as many people might write down. Okay, because when x is 0, y is 0. When x is 5, y is 10. No, because this is a quadratic. It goes down below this in this region here. The lowest it reaches is its vertex, because the vertex is in this region. So the range is actually between minus 2.25, including that, and we can say y less than or equal to 10, including that, because these this includes that value there, and here because that's the vertex, it reaches that point but doesn't go below it. So that's the range of this function. That's a very, very important question. A lot of people would write the answer as I did first, like this. This is not the answer because we have a restriction in the domain. Okay, so it's very important for you to realize that these things at the right at the end of the question are not there for just decoration purposes, right? They are there, okay, for for you to take note of, especially in these questions in functions in P3. Very important. A lot of people lose marks. They say, oh, that's a quadratic, has a vertex, it never goes below that, so the range is the vertex and above. No, you have this restriction in the domain, so you've got to think about where it goes. The highest and lowest reaches, the highest value and the lowest value that it reaches in that domain, because it starts at 0 and it ends at 5. It doesn't exist past 5. It doesn't exist past 0 on this side, less than 0. Okay, so there's the answer to part D, and I think that was the end of this question. Okay, that was the end of this question, I think. Yep. Okay, so I hope that was clear. I went on a bit, but I wanted to explain a few important issues. Now, other questions from this particular paper, June 2014, C34, can be found in the playlist, the link for which will appear over here. Other questions about functions in P3 will be found in the playlist, the link for which will appear over here, and you can subscribe to my channel by clicking on the link. Check out the details in the description underneath the video for other material you might be interested in. Thank you for watching. See you soon.